In this video series, we focused on this architecture. In the previous video, we created Cognito S3 bucket where we uploaded the template, the images that we want to use in Cognito invitation email template. In this video, we focus on VPC, subnets, network, subnet, and internet gateway, a main route table, and a route table for private subnet. To have a better overview of what we want to deploy this time, we draw a new architecture. Um, the focus is to private subnet or non-internal subnets and to public subnet where they have access to internet over main route in route table to internet gateway. The implementation or provisioning the resources will be done in Terraform. We go through the code to see the resources that we need. The code implementation you can find in my GitHub with tag 1, the extent of the default route table of the VPC. The implementation has this architecture or this structure. Architecture is wrong, but this is structure where I have general implementation of VPC, of subnets, and then we have a solution folder where I use or reference to the general VPC. It is a modular implementation of Terraform that we define general resources, general implementation of resources, and then we call the general implementation based on the solution that we want to develop under another repository or another folder. Because this project is not so huge or big, I use the second folder, which is solution. And under VPC, it is the whole implementation of the VPC that we need in this example. I go through the main resource that we need. The main resource is VPC. Um, Without having a VPC, we cannot create subnets. The subnets are sub-resources of VPC. I opened the general implementation or the module implementation of VPC. I tried to develop this as simple as possible. First, I started with VPC, and each VPC must have an internet gateway if it need internet connection. Therefore, I defined a with internet gateway as a Boolean variable to say or to determine if this VPC needs an internet gateway or not. If it's not necessary, then it will be false and the count will be 0. In this case, I will omit the internet gateway from the implementation. And if you look at the module side of deployment, you see that I said with internet gateway is true. It means I need an internet connection or access to internet via my VPC. And the second thing that I defined here is the route. In AWS platform or in AWS services, cloud platform, always VPC or virtual private cloud or virtual network is it, it has always a default route table. You cannot delete it. It's not possible, but you can configure it. as I have done here. Default route table, I referenced the default route table to the main route table of the VPC. We can never delete it, but we can configure it. In this section, I updated the tags of this route table, or the tags of the main route table. And then in the route, I add a route to route table to allow the 000 connection um, to be sent to internet via internet gateway. A VPC doesn't have internet gateway by default, therefore I created it here. And the default route table doesn't have internet access by default. We should add it, or we should insert this route to the route table via AWS route to say yes, all the destination CIDR blocks with 0000 have to be sent to this gateway ID, and this gateway ID is internet gateway that I have created here. You see that I has an index here is 0. It's because this count, when I'm using count, the resource is created with an index. When it is 0, the index, the resource will not be created. But when it is 1, one instance of this resource will be created, and indexes are started from 0. Therefore, I said as a constant value 0 because either I have 1 or 0. And then I updated the tags of the default route table. And then I started with private subnet and public subnet. Of course, both of them are subnets, but because I want to have different IPs via CIDR block, and different usability, um, I defined a private subnet and a public subnet. The public subnets are the subnets which are associated with a main route table, which is a route which redirect the 000 requests to the internet. And the private subnets are the subnets that are not associated with the main route table where I have a route for internet. They are associated with another route table, which I will focus on it in the next video. But I will explain it right now. The route table here for private subnets will be used if you want to use NAT gateway to have one-way connection to the internet. Sometimes for some scenarios you have to use NAT. It is not a must, but maybe your solution need a NAT gateway, and then the best way, or the best practice way, is to have a private route table or a second route table. This route table should have a route to a NAT gateway, and gateway will transfer your data to over internet gateway to the internet. And it is a one-way connection because the destination is in internet, but the source is from private subnet. The source cannot be internet. It means nobody can access to your private subnet from internet, but the resources in private subnet can access internet and get a response back. Let's get back to Terraform. I explained about the private subnet. They are non-internet subnet, public subnet. They access internet. Then we have a route table association. This part, as I mentioned here, associate public subnet with a default route table because public subnets contains or subnets contain resources which are allowed to access internet. For example, load balancer. In next videos, I will show you that I use public subnets for my load balancer and the private subnets for my Fargate cluster. And I will extend the infrastructure with a second route table for private subnet. One more thing that I should explain here is the naming convention. As you see in module implementation, I not only called the general module for VPC here, but also, for example, default route table name or public subnet name um, and private subnet name. I thought it would be a better solution to have a specific naming convention for the resources to consider the important information when you go to to AWS console and see the resources. You can even determine which resource belongs to which project or which stage. Of course, in best practices, we say that we have to have different AWS accounts for different stages, but it's not a must. It is only a best practice. Maybe your project is not so big to have different AWS accounts for two stages. You can even have three different stages under one AWS account if your project is not so big. And I do it. I do the same. I have in one of my small projects for AWS, I have only one AWS account and I deploy the resources for three stages, dev, acceptance, and production under the same AWS account. And the only way that I determine which resource belongs to which stage is the naming convention. And of course, I have a specific role definition that allow the developer to only access the services with a specific tag, not all the tags. For example, developers can only manipulate or delete the resources which belong to dev environment, but not prod or acceptance environment or stage. Let's go forward and deploy the resources. If you use my code, you can easily go to the VPC folder under solution. As I'm here, for example, I can show you exactly. And then you can say Terraform, or I can bring it here that you see it better. Terraform init. Then it will be asked what is your um, S3 bucket. You should have already created a S3 bucket to use it for Terraform state files. If you have any question about Terraform state files and how I configured it here, you can write a comment. I will explain it to you. And then Terraform apply. In the meantime, that the resources are getting deployed, I go through the local variables that I have here. Each VPC or virtual network must have IP address range or CIDR block. As you see, I have defined three different stages, and I use, for example, this range of IP address, and based on def stage, I have defined the CIDR blocks for subnets. In this example, because I have two public subnet and two private subnet, I only defined two private subnets in two different AZs or availability zones with two different IP addresses. And then I referenced in my modules to these local variables. It was one part, and then in naming convention, you can also go to Terraform name. I only wrote 0 here because I wanted to keep the module and the TF name at the top of the structure uh, to be easy for me to present it to you. For example, I go to VPC. VPC has an input variable where I pass project name, environment, and the region short name and the prefix that I need. Maybe it can be null also, and then output generate the name that I expected or the naming convention that I defined for my project. Most of the times I use short name or the abbreviation of the services in the service name, in the resource name. uh, it depends on you how you prefer to have it. The resources have been created. I go to AWS console. I do a refresh. Actually, I should have right now two VPCs or virtual network. One of them is the default network of AWS. I prefer not to delete it, and most of the time I don't use it in my projects. Of course, you can use it, but I prefer to have the VPCs that I create. Then I can manage all of them over my Terraform code and delete it, reconfigure it, or this stuff. As you see, I have a tag here. It's important to know the name tag in VPC will be used as the display name of the VPC in AWS platform. It's not the same for all the resources, but for VPC is like this. For subnets, then I can find my subnets easily, and each of them has tag because you see a display name, and the display name is the name tag that I defined here, and they are the another further tags that I use most of the times in my projects. Um, the next is Internet Gateway. We created the Internet Gateway, and you can see it belongs to this VPC. It is my VPC, and then we have route table. As you see, the route table, I used the default or main route table of the VPC that we can delete it never. But I wanted to determine my VPC between my VPC and between my route table and the route table of another VPC. Therefore, I used the tags, and I said I have a tag name which has this value sample def. This is my stage, and short region name. Default is the prefix that I wanted to have, and then RTB is the abbreviation that I use in my resource names in my naming convention. And then now I know this route table has been created when I created my VPC, and I gave a name to this route table. And then I can easily destroy these resources, destroy. Um, In the previous project, I show you that I have created a pipeline for it. For this example, I can show you here. I have two pipelines. One of them is for creation, the other one is for delete. In provisioning pipeline, I provision the resources based on the folders that I have under solution folder. For example, let's look at it. For example, here I have Cognito or I have VPC. I will talk about guard duty later. This video is only for VPC. I have a VPC folder here, therefore I have first a validation and then I have deploy VPC. It has some input variables because you can see it in variables. We should pass project name, environment, region, and cost, region short name, and cost center. I pass these values, for example, as var parameter to apply, Terraform apply. You can see it here. These variables you can define either here as a pipeline variables, or you can define as another they are dynamic variables, they are static variables. For example, I know region short name is always for me Frankfurt or Europe Central 1, but the stage must be changed based on the branch. And when I develop or when I use the develop branch, then the environment must be def, therefore I calculate it here dynamically. But the rest of the variable I have added to my pipeline variables as a constant value. And then after that I'm finished with my, for example, testing or feature branch or this stuff, then I can use another pipeline, which is destroy AWS resources. We can take a look at it, edit. Either you can use Terraform command line. It is only for development time, but when you are developing the infrastructure and your code together in a CI/CD pipeline, then you have to have integrated Terraform in your pipeline. And therefore, I have again destroy pipeline for exit cloud strategy. Sometimes when you are in vacations, it's not necessary that your acceptance and your dev environment is up and running. You can destroy or kill all the resources and only production have to be run. Therefore, this pipeline, the difference is this pipeline where I provision the resources is running automatically after that I commit a change or brand or pull request to my development branch and destroy AWS resources is not an automatic running pipeline. I should always manually run the pipeline. It was what I wanted to be manually runnable, not that it has it, it's not a mistake to be developed it as a manually running pipeline.